Okay, so I have this already set up like this because I'm trying to use similar examples and similar problems. This is an HA, it's that same HA reacting with water, so it's an acid. So it's giving to the H2O, become H3O plus, leftover A minus. And then we have an initial amount of this, and then these are both 0. Remember that we are subtracting from the reactants and gaining our products. So this should look really familiar to one we've already set up, and that's a Ka expression. Now, this problem is not new. You've solved a problem just like this on the last test with a nice chart, and you just had to stop at solving for x. This time, we're actually solved for pH, but if we know x is H3O plus, then we just know that pH is equal to the negative log of that number. And we're good. So it's just asking you to do one more step. Note, if you were given something like a base that produced something over here on the right side, like NH4 plus, so that'd be like NH3 reacting with water. Notice that this, when you fill it all in, you're going to have an X here and an X here. This same X is what you're used to solving for, but if we need the pH, just note that this is going to actually be the POH because we're talking about OH. And this will have one more step where you subtract 14 minus to get the pH. So if you're doing H3O plus and you make H3O plus, you can just turn your X right into your pH equation. If you are solving for something that has an OH group in it, you, again, just plug your H into your POH, but then you have to do an extra step to get to the pH. So just pay attention where you're doing these. There's plenty of example problems for you to see that. So the other thing to note about this is that there's a shortcut in math, and we're going to show that in the next section because this is, it feels like, oh, I just want to use Math Papa all the time. But I'm telling you, you don't want to. It's a kind of a pain to type things in. And there's a shortcut we're about to show you. It's used all around, and it's what you should use for weak acids. And it does make the math so much better. So when I go to fill this in, I haven't shown you the shortcut next, but it'll be in the next lesson. You'll see this exact same video, but we'll do it, and I'll show you where the shortcut is. So right now I have this, and remember that x times x is the same thing as saying x squared. And then it gives me the Ka is 5.00 times 10 to the minus 6th. So I'm going to just plug it in to this over here. That's 5 to the minus 6th. And I'm hoping this is not upside down. I can't control the direction that Math Papa wants to go when I'm recording. So I've got this already typed in. And when I calculate it, it tells me 2 options. And I need it to be the positive number. So it's that 0.001116. This is the 0.001116. Let me get it to shift back. There we go. So 0.001116 is equal to x. So to get the answer, pH is equal to the negative log of 0.00116. If I bring that over, bring my calculator up, I get negative log. And again, you don't get to, if you're already using your calculator, you can just like tap the number and that you had gotten for x, and you can just go ahead and put it in. But doing it this way, you have to retype it. I'm telling you, it's faster. And the little assumption method you're about to learn, it's just way easier to solve these kinds of problems. But that tells us that the pH is equal to 2.9, we'll do 3, nope, that's 4, 2.94. And that, if you're wondering about sig figs on this, this has 3 sig figs, this had 2. So our overall answer here would technically have 2, and pH is really weird because you just match with what falls off. It's like you pretend that the 2, the front part of the decimal, doesn't matter. You're just matching sig figs at the end. And I know that's weird, and that's just the way they do it. We will be telling you how many sig figs that you need.